Imagine standing in the shadow of the Great Pyramid of Giza, one of the 7 wonders of the ancient world. How did the ancient Egyptians align these stones so precisely without modern tools, or if you believe certain cable TV shows, help from extraterrestrial beings? While aliens make for entertaining theories, the real answer lies in the brilliance of early mathematics. From tracking the stars to constructing monumental structures, math has shaped human progress in extraordinary ways. Today, we'll explore its evolution from practical problem solving to groundbreaking theories, uncovering how ancient civilizations built the foundation for modern mathematics. Ancient Egyptian mathematics was deeply practical, rooted in solving real-world problems. With the annual flooding of the Nile, they needed reliable methods to measure and redistribute farmland. This gave rise to early geometric concepts. The Rhind Mathematical Papyrus dates back to around 1650 and offers us a glimpse into their knowledge. It includes formulas for areas of rectangles and circles, and even problems involving fractions. Their fraction system was unique. They used unit fractions, or fractions with a numerator of 1. For example, instead of writing 3/4, they'd write 1/2 plus 1/4. While that seems cumbersome to today's standards, it highlights their ability to break complex problems into manageable parts. And of course, Egyptian engineers applied these concepts to construct the pyramids, using tools like ropes and plumb bobs to achieve precise alignments. Their achievements laid the groundwork for later civilizations to explore geometry further. The Babylonian mathematicians were active around 1800 BCE and pushed mathematical thinking beyond what the Egyptians had achieved. Their base 60 number system is one of their most remarkable contributions. It's the reason that we even still today measure time in 60 minutes, or 60 minutes in an hour, or why circles have 360 degrees. Babylonians were also pioneers in algebra. They could solve quadratic equations and understood geometric relationships like the Pythagorean theorem long before the Greeks formalized it. Their clay tablets, such as the famous Plimpton 322, demonstrates knowledge of right triangles and even what we now call trigonometry. But why did they need this math? Babylonian society relied heavily on accurate land measurements for agriculture and used astronomy for calendar making and predicting celestial events. Their blend of practical needs and intellectual curiosity influenced future civilizations, including the Greeks. When we think of Greek math, we often picture geometry and proofs. But before Euclid, early Greek mathematicians like Thales and Pythagoras laid the groundwork. Thales, often called the first mathematician, introduced deductive reasoning into mathematics, proving basic geometric principles, such as the idea that a circle is bisected by its diameter. His work was revolutionary because it marked the shift from empirical problem solving to that of abstract reasoning. Pythagoras, famous for his theorem about right triangles, also connected mathematics to philosophy. His followers believed that numbers were the essence of all things. They explored ideas like numerical ratios in music, linking math to harmony in the universe. This shift towards abstraction, or seeing math as a way to understand the cosmos, was a defining feature of Greek mathematicians. No discussion of ancient math, though, is complete without Euclid, who's often called the father of geometry. Around 300 BC, he compiled Elements, the 13-book masterpiece that organized mathematical knowledge into a logical deductive system. Euclid's Elements begins with simple definitions, postulates, axioms, and builds from these to prove more complex theorems. His approach wasn't just about solving problems, it was about teaching how to think logically and systematically. This text became the standard for teaching geometry for over 2,000 years. Its influence extended far beyond mathematics, shaping philosophy, science, and even the way that we think about logic today. Euclid's work exemplifies how mathematical ideas can transcend their time. While Euclid is most famous for his geometry, he also made significant contributions to number theory. He explored the properties of prime numbers, stating that there are infinitely many primes, a result that's still taught today. One of Euclid's most practical contributions was his algorithm for finding the greatest common divisor of two numbers. This method is simple, elegant, and forms the basis for many modern algorithms that are used still today in computer science. By focusing on the fundamental building blocks of numbers, Euclid laid the foundation for later work in algebra and cryptography. Archimedes was living in the 3rd century BC and was a true mathematical genius and inventor. He developed methods for calculating areas, volumes, and surface areas that were precursors to integral calculus. His approximation of pi was remarkably accurate, and he invented the Archimedean spiral, a curve that's used today in engineering and design. Beyond theory, Archimedes was also an engineer. He famously said, "Give me a place to stand, and I will move the earth," referencing his understanding of levers. His war machines protected his home city of Syracuse from Roman invasion. Archimedes epitomized the blend of pure and applied mathematics. Apollonius of Perga, often called the Great Geometer, expanded the study of geometry to include conic sections, parabolas, hyperbolas, and ellipses. He formalized their definitions and studied their properties in detail. Why does this matter? These shapes became critical for understanding planetary orbits and later influenced the development of calculus and physics. Apollonius' work showed how abstract mathematical ideas could have profound applications in understanding the natural world. Finally, we arrive at Ptolemy, whose work bridged mathematics and astronomy. His Almagest presented a geocentric model of the universe, which, while incorrect, dominated scientific thought for over 1,000 years. Ptolemy also made significant contributions to trigonometry, creating tables of chords that were precursors to modern sine and cosine functions. These tools were essential for navigation and understanding celestial mechanics. His work illustrates how mathematical advancements often stem from humanity's desire to explore and understand the cosmos. As we've journeyed through ancient Egypt, Babylon, and Greece, and beyond, one thing becomes clear. Mathematics isn't just a tool, it's a story of human ingenuity. These early contributions laid the foundation for everything from architecture to astronomy, from navigation to modern technology. So the next time we solve a math problem or marvel at a technological innovation, let's remember, we're part of a tradition that stretches back thousands of years. Let's keep building on it.